Hi, so now let's continue our discussion on the integration of rational fractions. So we say that we have four cases. So this time we're gonna tackle the case 1, which is the denominator consisting of distinct linear factors. Okay, so for case 1, we have, rule. So rule for case 1. Okay, so our rule is that for every linear factor ax plus b, wherein our a here and b is constant, associate the partial fraction a, big letter A, all over this linear factor ax plus b, where our big letter A here is constant to be determined. Okay, so for illustration, we have, say, given 2x minus squared minus x minus 5 all over the x minus 1, x plus 2. So according to our rule, we need the for every linear factor of ax plus b. So we have 3. It is associated with partial fractions of in this form. Okay, wherein a, this numerator a here, is the constant to be determined. So for first linear factor, wherein our a here is 1, and then x, and then plus b is 0, so only have x. And then we have designate our unknown constant. So we have a x, and then we will add the next partial fractions of this form. So we have our a once again here is 1x, then our b is negative 1. Okay, so plus x minus 1. Okay, so in order for us to easily distinguish the numerator, let's use another letter for this constant. So say we have b, then plus this partial fraction, which is x plus 2, then our constant letter c. Okay, so instead of this form, we can rewrite it as like this. Okay, we have a over x plus b over x minus 1 plus c over x plus 2, wherein we need to determine the values of the constant. Okay, so last time we've done that on our last example here. Okay, so from here we used this transformation. But what if we are our given is something from here, so we cannot easily determine its equivalent fractions, right? Okay, so we will make these fractions into more simpler partial fractions. Okay, so so in the case 1, we have something like this. So we will associate this partial fraction a all over ax plus b. So we do this. So another illustration. Say we have 3x plus 7. This is 7 all over x cubed minus x. Okay, but this time, as you can see, it is not in the form of this one, ax plus b, because we need an x that is only raised to 1. That's why it is said here that the degree of px is less than the degree of 1. So if not, we need to do some modifications. So from here, we need to do some modifications in order for us to apply our rule. Okay, so we can do some little algebra here, wherein let us factor out x. So we have x squared minus 1, right? And then we can also do the completing of squares, wherein this x squared minus 1 here is also equal to x plus 1 then minus 1, right? So they are equal or the same. Okay, so after that, we are now in the form of partial fractions like this. Okay, so we can now do an equivalent partial fraction, which is equal to a all over the first part, and then plus b all over the second polynomial function, which is x plus 1, and then plus c all over x minus 1. Okay, so that is what we call the integration using the rational fractions, or using the case 1, this case. Okay, so after transforming your main integrand, say this is your main integrand, into partial fractions, then in order for us to easily integrate this one, we need to determine the values of these ABCs here, right? So for a real example,